Alright, amines. Okay. Right. Amines are organic chemicals with this group on the end, NH2. Okay, so NH. Okay, so we've got the same naming rules: meth, F, prop, but, pent, hex, hept, oct, up to 8. You need to know. Basically, we replace hydrogens with that NH2. So it's like an alcohol. We replace a hydrogen with an OH, right, like that. As an alcohol, for an amine, we just add an NH2. Okay, so same carbon chain structure. This can be 1, 2, 3, 4, 5. We only have to name up to 8, but we just replace, or we add in this NH2. It's an amine functional group. Rightio? So if we were to look at a chemical like this, we've got one carbon. One carbon means we name it with meth out the front. Right. If we have 2 carbons, for example, then it's F, and the name is methanamine, like methanol, but instead of ol, it's amine, ethanamine. Right, so they're named with the suffix of amine on the end of the word. Propanamine, butanamine, pentanamine, hexanamine, and so on. Right. If we wanted to do a condensed formula and a skeletal formula for these, so this is basically structural formula here, but if we wanted to do a condensed formula, right, so we're not drawing our bonds between our hydrogens and carbons. So that would be CH3 there becomes CH3, NH2, this one would be CH3, CH3, a 2, NH2. And for a skeletal formula, right, skeletal formula, we don't draw any carbons, we just draw our functional group and the bonds in between the carbons. So this one, like that. So we're just pretending that that carbon is there, that carbon is there. Just a really slack way of drawing organic chemicals. Okay, quickly, primary, secondary and tertiary structure of amines, same as primary, secondary, tertiary structure of alcohols. What we're looking at is, this is our amine group here. Right, in a primary amine, it's attached to one carbon, right? So this carbon is attached to no other carbons. Okay, it's got 3 hydrogens attached to it, no other carbons. Our amine group on this one is here, and what you look at for a secondary is it is attached to 2 carbons. 1, 2. And for a tertiary amine, that's all we've got left. 1, 2, 3. Okay. So if we wanted to write a quick definition, primary, our nitrogen is attached 1 carbon, secondary nitrogen attached to 2 carbons, tertiary nitrogen attached to 3 carbons. Make sense? Pretty straightforward. Okay, let's have a look at amine, amine group, NH2. What do we know about nitrogen?
Needs 3 bonds.
Nitrogen is yeah, it needs 3. Yeah, it's on the periodic table number 7. Nitrogen is number 7 on the periodic table. It has 7 electrons. All right. Electron configuration is 1s2, 2s2, 2p3 with 5 electrons in its outer shell, the second shell here. Right. Nitrogen in the form of an amine is sharing 1 electron with hydrogen here, 1 electron with hydrogen here, and an electron with this, whatever group's here, carbon. Okay, so if it's only sharing 3 of its electrons, but there's 5 in the outer group, we end up with 2 leftover electrons, and we call that an unbonded electron pair. What this means for amines is that they can act as a base, okay, and bases accept protons. We know that acids donate protons, therefore amines can accept protons from acids. Okay, when an amine accepts a proton from an acid, like down here, we've got an example amine here with its unbonded electron pair. We're adding some hydrogen or an acid, okay, positively charged. It is able to bond to that unbonded pair of electrons, and our product is what we call a protonated amine. And protonated amines are NH3 with plus. Okay, so what we just looked at was turning an amine into a protonated amine. If we want to go backwards from a protonated amine back to an amine, we add a base. Okay? So, for example, we'll use the same example we had before. We had a single NH. And if we add some base to it, so simplest base is just hydroxide, OH minus. Okay, could be sodium hydroxide or something like that. Right, what's going to happen is the opposite of what happened before. Hydrogen's going to leave the protonated amine to give us just a normal amine. Easy. So going forwards, to make protonated amines, amines gain hydrogen. To go backwards, the protonated amine loses a hydrogen when you add a base. Okay, let's look at solubility. We're not going to talk about, we're just going to compare the differences between amines and protonated amines and how it makes them have differences in solubility. What does solubility mean?
It's ability to dissolve in something.
Okay.
Like water.
Yep. So solubility is, the ability of a substance to be able to dissolve. We're looking at water. Okay, we're looking at solubility in water. I should make that clear. Solubility in water. Okay. So we draw some waters. All right. Is water polar or non-polar?
Polar.
Yep. Why?
Because there's a difference in electronegativity.
Electronegativity between
Hydrogen.
hydrogen and oxygen.
Mm-hmm.
Yeah. Oxygen's electronegative, hydrogen's not really. To signify that, we put delta minus and delta plus. Okay? The one with the highest electronegativity gets the minus because it's essentially pulling or attracting hydrogen's electrons towards it, so it gets a partial negative charge. The molecule's polar because the ends have different partial charges. That's considered an end. That's also considered an end, right? Because it's accessible, right? Other molecules can come in like this easily. NH bond. Is there a difference in electronegativity between N and H?
No.
No. Yes.
Is it yes to my no or no?
No, it's
to
a
my
no
yes?
to your no.
Right.
Okay, so N and H, we're in a similar territory here. What kind of bonding do you think we can get between there and there? We've only talked about 3 types of bonding.
Hydrogen.
Hydrogen bonding, right? Remember, hydrogen bonding occurs between hydrogen and something. Oxygen, nitrogen, or fluorine are the 3 that we looked at, that we care about. Okay, we looked at them. Did hydrogen bonding last in year 11? Okay. Oxygen, hydrogen can form a hydrogen bond. Nitrogen, hydrogen can form a hydrogen bond. So we get some hydrogen bonding occurring between here and here. Right, just label that. Okay. So amines or amine groups are able to hydrogen bond with water. So if we had a really small amine like this, 1 carbon here, do you expect it to be soluble if it can hydrogen bond with water?
Yeah.
Yeah, we would. What happens if we extend the carbons out? Happens to solubility when you make a molecule bigger.
Becomes less and less
Less.
soluble.
Yeah, it goes down, right? Because all these carbons that we add on here, they're non-polar. So this tiny little bit of hydrogen bonding here is not going to be enough. But if it's a really small one like this, with a carbon there, then it will definitely be soluble. Okay? So I'll just write that amine groups are able to hydrogen bond with water. I'm not going to say that it makes them soluble or anything. Let's have a look at this protonated amine. Let's have a look. Polarity for water is the same as it was over there. It's always the same. Delta positive, delta negative. What do you think is going to happen between this full positive charge, so an entire positive charge, and this partial negative charge?
Stronger bond.
Yeah, they're going to bond, right? We had a name for this type of bonding. This is called an ion dipole bond. Okay? So we can signify that. Ion dipole bonding. Right, this is very important. Okay? Ion dipole bonding occurs between protonated amines and water, and also between carboxylic acids that have become an ion, carboxylate ions. They will also ion dipole bond with water, and then they makes them dissolve really easily. Okay, this bond here is a lot stronger than that bond there because we've got a full positive charge here. Right over here, we've only got partial charges. Okay, so we can write protonated amines are able to ion dipole bond with water. Okay, amine groups are able to hydrogen bond with water. Protonated amines are able to ion dipole bond with water. Ion dipole bonds are stronger than hydrogen bonds, therefore protonated amines are more soluble than amines. Okay?